This is homework 1. We'll be doing problems 1, 3, 11, 14, 24, 26, and 46. Let's begin. Number 1 says, starting with the definition, 1 inch equals 2.54 centimeters. Find the number of kilometers in 1 mile and feet in 1 kilometer. All right. So we're starting with the definition. 1 inch equals 2.54 centimeters. And we need to know how many kilometers in 1 mile. All right, so 1 mile. I'm just going to convert until I get to kilometers. All right, so I would know I know that 1 mile is 5,280 feet. And then over 1 mile. And I can multiply it by this because this is just 1. An expression called unity. And it's equal to 1. It's like 8 slices over 1 pizza. Anyway, so that's 1 mile and 5,280 feet. And then I want to get rid of the feet. So I'm going to go 12 inches, 1 foot. All right, now I've got inches to contend with. And I've got that definition, 2.54 centimeters in 1 inch. Finally, we've got 1 meter, and that's 100 centimeters. And last but not least, we've got 1 kilometer and 100 meters. Let me get my calculator. Figure this whole thing out. Here we go. All right, 5280. I get 1.6. All right, 1.61. And since I started with this definition and I'm doing multiplication, I can only have 3 sig figs. So I get 1.6. So that's that one, that's A. Give myself some board space. For B is how many feet in 1 kilometer? Okay. Here we go. 1 kilometer times 1,000 meters over 1 kilometer. When you get real good at this, you can leave out the denominator, but we'll go ahead and do it nice and slowly. We're going to feet, right? Times, we need to get to centimeters. 100 centimeters in 1 meter times 1 inch in 2.54 centimeters. And finally, 1 foot in 12 inches. And let's see what this gives you. All right. I get 3,280 feet. All right. That's problem 1-1. All right, so that one's done. 1-3 says, how many nanoseconds does it take light to travel 1 foot in a vacuum? The result is a useful quantity to remember. Okay, so we have speed of light is 3 times 10 to the 8th meters per second in a vacuum. We need to convert that to feet. So we're going to do, I guess we'll start with that definition, 2.54 inches in a foot, in a centimeter. All right. Then we're going to do 100 centimeters, 1 meter. We're going to go to 1 foot, right? Let's see. Yeah. All right. 1 inch to 2.54 centimeters. And then finally, 1 foot to 12 inches. And that's going to be how many feet per second. And I'll just take the reciprocal to get, oh, I got to convert to nanoseconds. Let's see. Well, I'll do that after let me take it one step at a time. Oops, clear. 3 times 10 power of 8 equals times 100 equals divided by 2.54 equals divided by 12 equals. Okay, so the speed of light in feet per second would be 9.8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 feet per second. I got to do nanoseconds, so let me go ahead and do that. Would be let's see, 1 second and 10 to the 9th nanoseconds. So that's going to be, let's see, 9.8 times 10 to the negative 1 feet per nanosecond. And so take the reciprocal. Let's see. Okay, that's going to be 1.0 feet in a nanosecond. I get 1.016, but I have to observe my significant figure rules. Number 11 reads, in the fall of 2002, scientists at Los Alamitos National Laboratory determined that the critical mass of Neptunian-237 is about 60 kilograms. Critical mass of a fissionable material is the minimum amount that must be brought together to start a nuclear chain reaction. Neptunium-237 has a density of 19.6 grams per centimeter cubed. This is 11, by the way. And we indicate density by this Greek letter rho. And so that's Neptunian. That's 19.6 grams per centimeter cubed. And by the way, another little thing that you should know is in our labs, we're going to be either using gram centimeters or kilograms meters, mostly this. But those are the two systems of units, combinations of units you're going to be using in physics. It's either the gram centimeter or the kilogram meter. So since we do labs, we generally use pretty small quantities like gram centimeters. Anyway, back to the problem at hand. Neptunium has a density of 19.5. Sorry about that. 19.5 grams per cent. What would be the radius of a sphere of this material that has a critical mass? All right. So we have 60 kilograms, right? All right, so I'm just going to go ahead and convert. I can't do the critical mass. Okay, M critical of Neptunian. How did they indicate it? Let's see. We'll do the M critical of MC, and we know we're talking about is 60 kgs, but I can't do kgs in grams. So I'm going to go ahead and convert this guy to grams. So that's going to be what? 60 kgs times 1,000 grams per 1 kg. It's going to be 6.0 times 10 to the 4th grams. All right, that is my mass critical in grams. I need to find the critical volume, and then I'm finding the critical radius of the sphere. All right, so the volume, I'm going to go ahead and divide by this to get the volume. So 19.5 grams per centimeter cubed. Let's see what we got there. 6 times 10 to the power 4 divided by 9. Oops. 19. I'm going to get a volume of 3,076. Okay. 3076.9. And I'm going to take this, observe the significant figure rule at the end when I finish all my calculations. Okay, so that's going to be my critical volume, and that's in centimeters cubed. All right, now I need to find the radius of a sphere. So the radius, volume of a sphere equals 4/3 pi r cubed. So I'm going to go ahead and set this up and find out what radius I need. Equals 4/3 pi r cubed. Let me go ahead and do 3076.9 centimeters cubed times 3/4 pi. And then that's going to equal r cubed. I'm going to take the cube root of both sides. And I'm going to come up with 9 centimeters. All right. So you do the math and you come up with that. That was number 11. It would be 9.0 actually, if I'm being exactly correct. You were given 2 sig figs, and since it's a multiplication, my answer can have 2 sig figs. All right, this is going to be number 14. Number 14 says, with a wooden ruler, you measure the length of a rectangular piece of sheet metal to be 12 millimeters. So it's rectangular 12 millimeters, one edge. With micrometer calipers, you measure the width of the rectangle to be 5.98 millimeters. The length, width equals 5.98 millimeters. Use the correct number of significant figures. What is the area of the rectangle? The ratio of the rectangle's width to length, the perimeter of the rectangle, the difference between the length and the width, and the ratio of the length to the width. All right. Area. A equals length times width. So this is going to be 12 millimeters times 5.98 millimeters. And that's going to give me 72 millimeters squared. All right, since I'm doing a multiplication function, I can have no more significant figures than in the value with the fewest amount of significant figures, which would be this guy. There's 2 sig figs there, so I have 2 sig figs in my hands. All right, finally, that's A. B is going to ask me for the ratio of the what? Wait. Yeah, sorry, 1 minute. The ratio of the rectangle's width to the length. So the width up, so this is A, and B is going to be 5.98 to 12 millimeters, and that's going to be 0.50 millimeters. Oh, no, nothing. No units, right? Because they cancel out. And once again, I'm doing a multiplication division function, and I can have no more than 2 sig figs. This guy doesn't count, so I get 0.50. All right, C is what? The perimeter. C asks for the perimeter of the rectangle. This is an addition function, right? Perimeter is one, yeah. Oh, let's see. So I've got 12 millimeters plus perimeter, right? 5.98 millimeters plus, why do I have 6 millimeters in the, plus, let's see, 12 millimeters plus 5.98 millimeters. Oh, let me pause for a minute here. All right, let me go ahead and do this on clear. 12 plus 5.98 plus 12 plus 5.98. and 35.96. 35.96. So now when I add or subtract, I can have, it's the number behind the decimal point that matters. So I can have no more sig figs than the amount of sig figs to the right of the decimal point. Now for the answer in the solutions, they give 36. But I guess they did 2 times 12 millimeters plus 2 times 5.98 millimeters, which would be a multiplication function, which would mean they could have no more than 2 sig figs, but I did mine differently. I just added up everything. So yeah, D says the difference between the length and the width. So the length is 12 millimeters minus 5.98 millimeters. And that's going to give me 6.02 millimeters. Okay. E. Oops. E. E says the ratio of the length to the width. So that's 12 millimeters divided by 5.98 millimeters. And that's going to give me 2.0. All right. That was 14. We're on 24. For the vectors A and B, use a scale drawing to find the magnitude and direction of the vector sum A plus B, the vector difference A minus B. Use your answers to find the magnitude and direction of minus A minus B, B minus A. All right. A, where's A? A and B, okay. A is here. Let's see, here's our coordinate system. A goes straight down 8.00 meters, and that's vector A. And vectors have the little arrow above them. B comes up here, and let's see, it's 30 degrees, and this magnitude of B is 15 meters. All right. These are the magnitudes. Probably not correct to do the arrow sign, though I don't want to clear. All right, so if I'm going to add them, I add them tip to tail. So I will take this guy here, and I'm going to add A here. Very hard to do this on the whiteboard, but what you're going to do, you're going to take this, you're going to determine a scale that's going to be 15 meters. You're going to say maybe 1 centimeter equals 1 meter. And you'll take your ruler and you'll protractor, and you'll make sure this is 60. And you'll do, say, 15 centimeters this way. Then you're going to make sure this goes straight down 8 centimeters. And then you'll add them tip to tail here. You want that guy. So then you'll get some kind of angle here. And let's see. I think I did it by law of cosines in there. So I know that this is 90, right? Wait, that's 30. That's 90, so that's 60. So this has got to be 30 here. So I use this 30, and let's see, this is 15, this is 8. So I'm going to go for that. So is what c squared, or c equals the square root of a squared plus b squared minus 2 ab cos c. Make sure that that's, yeah, that's the law of cosines. And I just verified it that way. And let's see, what did I get? I got 9. It should be 9. Once you have that, it's you can get the angles using the law of sines, right? So the law of sines says a over sine A equals b over sine B equals c over sine C, where these are the lengths of the sides. So you want this angle, you can take 9 over sine 30 equals 15 over sine, we'll call this C. Oh, no, wait, this is sine B. Call this angle B. Sine B. And let's see. And let's see, I did it for the other one. I did 8 over this guy. Okay, that's what I did. Let's say 8 over sine A. And I got 34. Yeah. Then in order to get the angles of a triangle equal to 180. So you just add 34 degrees plus 30 degrees, 180 minus that. And let's see, 180 minus 64 would be 116. So this has got to be 116. But go ahead and do it with vectors graphically. So what you're going to do is you're going to set up some kind of scale on your page. Maybe 1 centimeter equals 1 meter. That would probably fit on the page. And just go ahead and do them tip to tail. So that was that. Also, you do A minus B. For A minus B, you're just going to, let me clear this. Go ahead and do them tip to tail, and then you can verify them using law of cosines and law of sines. So, eraser. So you should know how to do this from, I guess, trig, right? Or maybe calculus. But either way, some kind of math class, I'll just give you the refresher right here. A minus B is just A plus negative B. So you got your, wait, A was, that's B, right? So A is here and B goes this way. Oh, I did B plus A, but B plus A equals A plus B anyway. So B goes that way. So you would take B and you would go this way, right? And then add them there. Okay. And then A plus negative B would be this, and negative B is going to be this. So your final vector is going to be that. And finally, B minus A, which was the first one that I did. Okay. See also exercise 131 for a different approach. I think we did the different approach. That's law of cosines and law of sines. So go ahead and do that. Get practiced with this because we have a lab that asks you to add vectors graphically. So you might as well get a jump start on that. This is 26. We're going to do 26 now. Problem 26. All right. 1.26. Says a spelunker is surveying a cave. She follows a passage 180 meters straight west. Something like that. All right. Then 210 meters in a direction 45 degrees east of south. So that's south 45 degrees. This is just about there. 280 meters. No, 210 meters, sorry, 210 meters. Then 280 meters east of north. North is here, east of north, so she's going to go there. 280 meters. All right, after a fourth displacement, she finds herself back where she started. Use a scale drawing to determine the magnitude and direction of the fourth displacement. All right. So the fourth displacement is going to be this. And to do the scale drawing, what you're going to need is a compass and a ruler, and you're going to set up some kind of scale, maybe a 1 centimeter equals 10 meters. That seems like a logical way. Yeah. So you'd have 18 meters going that way, 21 that way, and 28 going that way. And then you'll do these angles very carefully. This is going to be straight on the x-axis. This is going to be 45. And this guy is going to be 30. So, yeah, you could do it that way. Or this guy's going to be 75, right? But I would do that 30. Anyway, I'm going to do it by components. And so you can do it both ways. Give you good practice. Okay. So this guy, this first one, we want x1, y1. X1 is just simply going to be negative 180. I don't need any math to do that, meters. And y1 is going to be 0 meters. And then this guy is x2, y2. So x2, y2. And I'm going to recognize it's going to be in the fourth quadrant. Fourth quadrant, x is going to be positive, y is going to be negative. So we're going to have 210 cos 45. And this is going to be negative 210 sine 45. So let's see, our values are going to be 148 and negative 148. And then finally, our third guy, it's going to be in the first quadrant. Yeah. So we're going to have x3, y3. And I'm going to go ahead and use this angle, 60. That way I can write it in terms of cos and sine of 60. This way I'd have to do cos of 30, cos of 30 for the y component, right? 30 cos I'd have to do for the y. I just don't want it, it'd be too confusing for me. I'm going to always do it in terms of that angle with respect to the x-axis, so I can do my conventional cosine and sine values. So it's going to be 280 cos 60, and that's going to be 140, and that's going to be 280 sine 60, and that's going to be 242. Now I can go ahead and add up my resultant vectors, and I'm going to go, the summation of the x's is going to be 108, and summation of the y's is going to be 94. Now, in order to get my resultant vector back to here, I'm going to take the negative of these. So x resultant is negative 108, and y resultant is negative 94. Okay, so now that's great. I've got my Cartesian coordinates. Now we love to convert to polar when we're doing this stuff. So let's go ahead and do that. Need to convert to r theta. So r is going to be the square root of x squared plus y squared. It's going to be the square root of negative 108 meters squared plus negative 94 meters squared. And r is going to be equal to 143. Now, in order to get my angle, it's going to be, right, I'm in the third quadrant, right? I'm just going to go ahead and get my angle with respect to the x-axis here. So tan of y over x equals theta. So tan of negative 94, tan inverse of negative 94 divided by negative 108 is going to give me 41. So I have to recognize that this is in the third quadrant. So what I'm going to do is add 180 plus 41. So my ultimate angle is going to be 221 degrees. That's where I'm at. Okay, that was 26. Now I'm going to do 46, 1.46, which reads, for the two vectors in figure 135, find the magnitude and direction of the vector product A cross B and the vector product B cross A. A cross B is going to be A, magnitude A, B, sine theta, which is the angle between them. So let's see what we got here. We got something like this. A is this guy, and B is this guy. And I know I got 60 here and 60 here. So it's going to be, and A is 2.8. So it's going to be 2.8 centimeters. Times 1.9 times sine of 120. Okay. So on sine of I get wait a minute, let's see. Clear. 2.8 times 1.9 equals 5.32 times sine of at 4.61. And A cross B, I'm taking A, crossing it to B, and I can see that that's coming out of the page. So the direction is going to be out of the page like that. That's how you indicate that. B cross A is going to be just 1.9 times 2.8 times sine 120. It's going to be the same thing, but B cross A is going this way. And if I keep on going that way, that's going to screw into the page. So this is going to be into the page. And that's 1.46. And that concludes homework 1.